Hi, welcome. In this particular video, we will be talking about implementation of stack using linked list. Okay, so let me revisit the stack. What is a stack? Stack is one abstract data type, right? And the basic principle of stack is last in, first out. What exactly we mean by last in, first out? Means anything that we, let's for example, a pile of books, right? So if you want to put a book, you will always put at the top of the the stacks of book that you will be having, right? So in one particular n only, we're going to insert and we're going to delete also. So for example, if you have a list like this, say 12, 14, sorry, 15, 7, 18. Okay, now if I want this 12 is at the top. uh, I have a list, and let's say 12 is at the top of the list, right? So if I want to insert something like 17, so I will insert, okay, here, and now 17 will become the top. Okay, and this is what is this is what we call it as a stack, right? So if you want to insert some element into the stack, that the function that we call it as nothing but push. If you want to delete something, then we call it as a pop, right? And the insertion and deletion will be always be at one end of the stack, right? So which is usually called as the stop. Now, if you want to represent using stack using a linked list, so that means each of these 17, 12 will be a node, okay, and will be connected each other. So I declared one particular structure node, okay. And if you remember in the linked list, I have mentioned that the starting element of the list is pointed by start. So here, since at one n only we are inserting, and we say this is the topmost element, so I mentioned this as a top, right? And initially I mentioned top is equal to null, right? And I created one menu, yes, where push an element to the stack, pop an element from the stack, display the stack, and exit, right? Okay, and as a switch case, I have created this function push, pop, display, and exit. Okay, if it I if, number four, okay, and default if you have entered any kind of wrong choice, right? Now let us start inserting the element. That means I write push function. Okay, so void push. Okay, I hope it is clear. So this is what the node itself, and why top? Because in the stack we said the topmost element is represented by top. So to make the convention clear, I mentioned this as top itself. Okay, right? And this is the menu as usual. Okay. So now push. Okay. First, I want to push an element, right? Okay. So let's say I suppose, okay, yes, right, and then I will create a struct node, okay, start new new node. Oh, yes, okay. So now I will assign the memory location to the new node, so we know how it does. Okay, struct node, okay, start, because malloc will be always returning a pointer to void, and I need to typecast it. And what typecast I have to do, because my new node is a pointer of type, struct node. So that is the reason why struct node. So malloc, okay, malloc takes one argument, that is the size of what? Size of the struct node. Okay, so that's amount of memory location I've given. Okay, now I will ask the user printf, okay, enter the number to be pushed. Yes, so then the scanf, okay, percentage d ampersand and new m. Yes, okay, great. And then I put new node. Okay, what is the thing that I played info? Yes, so new node info equal to num, right? Yes, so I have created the node. Okay, whatever number I have stored there. Now I have to check if the stack is empty. That means top will be empty, right? Top equal to null, right? Then what I will be doing, I will just simply write new node. Okay, I will simply write, top is now equal to new node. Okay, okay, and new node. Okay, next equal to null. Okay, yes, fine. Yes. So now my top will be pointing to my new node, and my new node will be next equal to null itself, right? Okay, yes, because one is the first element. Else, it is not the first element. What we're going to do? This is very easy, right? If it is not the first element. That means my new node now should point to whom? The new node must point to my new node must point to the top. So my new node next will be equal to top, because now my new node is now the topmost element. Okay, and top will be equal to new node. Now the new node, my top will be pointing to my new node. Yes. Say for example, nothing was there. Top is it was null. So I insert 12. Okay. So 12 of next will be equal to null. Okay. Now this will be my top. Yes. So that is what I have. Now already I have element. Okay. I already have this 12 and null. Now I'm inserting 13. So 13 is my new node. My 13 is my new node. So my new node of next is pointed is 12, right? Is 12 because 12 is the topmost element, right? Yes or no? And now top was pointing here. Yes. Now top will point to 13. So top equal to new node. So this push operation is done. Okay. Now let us go to pop. Okay. Void pop. Okay. So initially pop, I will check if, okay, top equal to null. Then I will simply write, I will simply write printf the stack is empty. Yes. So yes. Okay. Right. Then I just need to print, right? So I take construct node star, ptr. Okay. I want to take int num. Okay. So next means I have to display, right? Yes, I can write, printf. I don't require num also. I can write printf. Okay. The element to be deleted is, okay, percentage d. Simply I can write like this, top of info. Yes, I don't require this, top of info. Okay, then I can write here ptr equal to top. Okay, and top equal to top next. Then I move to the next element. Okay, and I write here free ptr. So I remove the location. So now here, see, I'm copying again this. Okay, so here I will put. Now I want to remove 13. Yes, so I remove 13. Now top was pointing to 13, right? Now I said ptr equal to top, means now ptr is pointing to 13. Okay, now top equal to topness. Now top will pointing to here, and then I write free ptr, means I remove this. Simple. Okay, right? And if top is equal to null, I say stack is empty. Okay, display void. Okay, display. Okay, so here also I will simply copy this, because if top is equal to null, I will simply copy everything. Okay, yes, if top is equal to null, stack is empty, else. Okay, right, what I will write here, ptr equal to top. Okay, while ptr not equal to null. Okay, I will simply printf. I will write simply here printf percentage d. Okay, ptr. Okay, info, and then I will write here ptr equal to ptr next. Yes, that's all. So now if top is equal to null, stack is empty. Okay, then I write ptr equal to top. Okay, so ptr now pointing to my 13. Okay, so means will be 13, then ptr next, which will move to 12, then ptr will move to, okay, null, and this will come out and it will display 13 and 12. Okay, so let us save and then execute it. So I will execute. Okay, expected Oh, yes. Okay, fine. Save. Let me execute. Yes, so I think you have this. Push an element to the stack, pop an element from the stack, and display from the stack. I said push, right? So what is the number that I can push? Suppose say I will push 12. Okay, then push set 30 to 4, push then 45. Okay, so I have, okay, so I have done, yes, so I push 34, 45, 12. Okay, let me display it. So level 3, yes, so I got 45. Okay, 12 and down. Okay, so I will do, let me pop out. So element to be deleted is 45 because yes, 45 at the top. Okay, then element, okay, again I'm pushing it. Say I'm pushing 56. Okay, let me display. So I get 56, 34, 12. Okay, 56, 34, 12. Okay, let me popped. So if I pop by 56 is gone, I have popped, 34 is gone, 56. Okay, then again popped, 12 is gone. Okay, then again pop. Okay, stack is empty, right? Okay, let me make a little bit of more visibility. Okay, so again, the element to be deleted from the stack slash n. Stack is empty. Enter the element to be pushed. Okay. Okay, fine. Let me save. Again, execute. Okay. So let me first display. So it will say stack is empty. Let me pop. It will say stack is empty. Stack is empty, right? So let me push. So I push 12. Let me push 1. Let me push 34. Okay. Now let me display. So I get it, right? 12 and this. Correct? Okay. Now let me pop. So 34 will be popped. There's a popped element is 34. Let me pop. Pop element is 12. Let me pop. Stack is empty. Okay. So I hope, sorry. So I hope this is clear. Okay. So let me explain again. So let's say I have this list of element. Okay. Right. Maybe I will remove this and I will just simply copy this. 13, 12 like that. Okay. 13 and 12. Okay. Right. So stack, all of us know, insert at one end, delete also at the same end, okay, right? And it is represented by topmost element is represented by top. So that is the reason why in the structure I have mentioned as top. Operation push, pop, and display. So I am using this menu, right? And in the switch case, right? First, what I have done is that I have taken the new node, okay? Struct node star, as I was telling you, because malloc returns a pointer to void. What type of new node is pointer is struct node. So what is the size that I have to give? How many bytes? It is the size of struct node, whatever the size will be of this particular structure, right? Okay. So then I take the element to be inserted. Then I will check whether if it is top is null. That means stack is empty. Then I will let top equal to new node. Now my top should point to my new node. Okay, the element that I'm inserting. Suppose I'm inserting 12, right? And 12 of next is null. Now it is not that 12 is already 13. So right, I will write new node is 13, right? So new node next is top because top is pointing to 12 and top equal to new node. Now my top must point to 13. Yes. Similarly for pop, I will check if top is null. Then I will take out the element. Okay. I will display the element. Then I will let PTR equal to top. So PTR is now is pointing to this 13 and top is also pointing to 13. Now I let top equal to next because once it does, topmost element will be 12. Okay, then free PTR, I have removed the PTR. Similarly for display, if top is now nothing which type empty, so I take a PTR equal to top and I traverse till PTR is not equal to null and I print the element. Okay, so I think implementation of stack is very easy in order to do so. Okay, I hope it is clear. So if you are liking my video, kindly share my video with your friends and do subscribe my videos because I'm coming up with more other not only data structure, I'm coming up with HTML, CSS and other videos also. Okay, thank you so much for watching.